In this video, we will be talking about rational exponents, converting between exponential and radical form, and then simplifying. So expressions with rational exponents can be rewritten as radicals using the following rules. So for exponential form, I have something to a fractional exponent. So we say that's the nth root of a. So in radical form, it would be I don't know. I'll rewrite that because something popped up. So I'll zoom in. The nth root of a. And then for a to the m divided by n, we say that's the nth root of a raised to the mth power. So the nth root of a raised to the m. So we're going to write each of these expressions in radical form and simplify if needed. We're going to stick with the odds this time. So if you want to think about it this way, this is m is exponent divided by root. So think about it alphabetically. Exponent e comes before r, so exponent comes before the root in the fraction. So here I have 1 is my exponent and 4 is my root. So I'm going to have the fourth root of x. And I can't simplify that, so there's your answer for that one. 3, I have 24 to the 1/3 power. So that means exponent divided by root. So I have the cubed root of 24. And 24 does simplify. 24 breaks into 8 and 3. And 8 is a perfect cube, which is 2. So I have two cubed roots of 3. And you would need to show this here to get full credit. And then 5, we have k to the 7/2. So it's exponent over root. So it's the square root of k to the 7th. Well, there's 7 k's, and I can take out how many groups of 2? I can take out 3 groups of 2. So k cubed, square root of k with 1 left over. And then I have a b both to the 3/4 power, so I'm going to have to distribute that 3 to both the a and the b. So it's exponent over root, so it becomes 4, the 4th root of a b cubed, which is also equal to the 4th root of a cubed b cubed. And I would want you to write it this way, since it cannot be simplified, so you know what that exponent means. Then 9 here, I have 7 times 12w to the 1/2 power. So 7's hanging out on my outside. And then I have the square root of 12w. And 12 does simplify into 4 and 3. So I will have 14 square roots of 3w. So that's how you go from exponential to radical form. And now we're going to go from radical form to exponential form. And just for continuity, we are going to stick with our odds. So 11 here, I have the square root of xy. So remember, there's an invisible 2 here. So I'm going to take xy, and it's just to the 1st power, so I'm going to take it to the 1/2. So xy to the 1/2. The cubed root of 11 squared becomes 11 to the 2/3 power. 15, the square root of 3m to the 7th power is 3m to the 7/2. Then last but not least is 17, which is 10 to the 5th power, the square root of 10 to the 5th power, a cubed b. So I have 10 to the 5th power, a cubed b, all to the 1/2. So you could have 10 to the 5 halves, a to the 3 halves, and b to the 1 half. Or leave it, either way. Alright, moving right along. So that's converting between the two. Now we're going to simplify expressions with rational exponents. So when you're doing this, rewrite all your radicals in exponential form. Use your exponent rules or laws to simplify the expression, and then write your answer as a radical and rationalize if needed. We'll stick with the odds. Alright, so 19 here. I don't have to write, they're both written, there's no radicals. Let's put it that way. There's no radicals, so they're in exponential form. So I'm just going to add my fractions because I'm multiplying two things. So I have x to the 5/3. And then, so that would be, well, I can take out one group of 3. And I'm left with how many? 2. Or you could do it as x to the 3/3 times x to the 2/3. Which gives you this here. Alright, and then I have 21, which is m to the 5 halves divided by m to the 7/4. So let's just make these fourths. Let's make this 4 and make this 10. So now I can subtract. I have m to the 3/4, which just becomes the 4th root of m cubed. So 23, I have a 32 to the 1/2 raised to the 1/2. So remember when you have exponents raised to exponents, you're going to multiply those exponents together. So you get 32 to the 1/4 power. So then we're going to take the 4th root of 32. And 32 breaks into 16 and 2. And 16 is a perfect fourth. So I have 2 4th roots of 2. What about this negative exponent? I have 100 to the negative 1/2. Well, that means that the negative is going to go on the bottom. So 100 to the 1/2, which is 1 divided by the square root of 100. The square root of 100 is nice, which is 10, so we get 1/10. Alright. So then I have negative 216 to the negative 1/3 power. So I'm going to, once again, like I did with 25, I'm going to drop that negative 216 to the 1/3, negative 1/3 power to the denominator. And then 1/3 power means I'm going to take the cubed root of negative 216, and it's over 1. And the cubed root of negative 216 is negative 6, so I get negative 1/6. $29. So up at my directions, it said I needed to write them in exponential form before converting all my radicals to exponential form. So let's do that. So I have a cube, because I can't do anything with this right here, because one's a cubed root and one's a square root. But if I change them to exponential form, I'm good to go. So I have b to the 1/3 times b to the 1/2. So I'm going to add those two together. 1/2 plus 1/3 gives me 5/6. If you don't remember how to add fractions, go back and review that. And then I'm just, 5 isn't bigger than 6, so I can't simplify it. But I need to write it in radical form. So the 6th root of b to the 5th. 31. I have 4 divided by the cubed root of 4. Alright. So once again, we need to rewrite our radicals. into exponential form. So I have 4 to the first divided by 4 to the 1/3. Well, that's going to be, when I subtract, 4 to the 2/3, which becomes the cubed root of 4 squared, and 4 squared is 16, and the cubed root of 16 isn't super nice, but it breaks up into 8 and 2, and so I have 2 cubed roots of 2. Alright, last but not least, I have the 4th root of x to the 10th. So I'm going to rewrite that as in exponential form as x to the 10th over 4, which simplifies to x, I'm jumping the gun and writing the x to the 5 halves. And I can take out 4 x's, or 2 groups of 2, and be left with 1 underneath my radical. So I'm going to have x squared times the square root of x. So that's rational exponents.